Okay, so in this lesson here, we go through some additional math topics that may be a little familiar for you. So let's get to it. So first off, in geometry, anytime we talk about bisect, what bisect means is to divide, right, into two equal parts. Okay. Now in geometry, we say equal, but equal for us means at times also congruent. Okay. Now another term you might see is midpoint. And a midpoint is a point that divides a segment into two congruent segments. Okay. Now, the thing about, the difference between a little bit between bisector and midpoint is a bisector can bisect an angle, right, or a segment. So right away here, one thing we do in geometry where we're heading is for proofs, and you have to know how to find a conclusion based off of a given statement and give the proper reason. And the first thing is if we're given, right, if we're given XY bisects AC, what can we conclude from that? Well, we can conclude that since XY bisects AC, it cuts AC in half. So we could conclude that AB is congruent to BC. But we almost have to be like lawyers here and give a reason why. And our reason why is if a segment bisects a segment, then what did we get in the end? Then two congruent segments. Okay. And if you look here, right, the if part of this reason, right, always relates to what was given. The then part of this statement, right, always goes back to what we concluded. All right. It summarizes what we concluded. So that always helps define what we're doing here. So if we're given OK is congruent to KP, what can we conclude here? Well, you could say JM bisects OP, but the one I like is K is the midpoint of OP. So what's our reason? If two congruent segments, then we have midpoint. Okay. So right here in example 3. In example 3, it says given OM is x plus 10, MP is 2x minus 8, and OP is 44. They want to know, is M the midpoint of OP? Well, here's the thing. The first thing we have to actually use is what we call segment addition. Meaning, if we add these two segments up, we should get that. That is the only thing we can assume. We don't know that M is the midpoint, but we do know that these add up to 44. So I'm going to use that statement, x plus 10 plus 2x minus 8 equals 44. Now, when I combine like terms, 3x plus 2 equals 42, or 44, sorry. Now I'm going to subtract 2. 3x equals 42. And right away when I divide by 3, you get x equals 14. So now how do we check to see if M is the midpoint then? Well, I'm going to plug this value of x back in. 14 plus 10 gives me 24. Then 2 times 14 minus 8, it's going to give me 28 minus 8 is 20. Now, is M the midpoint of OP? And the answer to that is no, right? Because OM is not equal to or congruent to MP. Okay? So you have to know that if that was the midpoint, OM would be congruent to MP. Now, a median is a segment that goes from a vertex to the midpoint of the opposite side. So right away, if I have a triangle, right, no matter what, a triangle can have 3 medians. If I find the midpoint of this side, right, and I draw this in, that there is a median, then if I find the midpoint of this side, right, and draw this in, right, that would be a median. And again, I can draw a third one, find the midpoint of this side, and that would be a median. Okay, so basically a median gives you midpoint. So right away they give us TW is a median. So if TW is a median, I know right away SW is congruent to WV. Now if TW, right, is x plus 40, SW is 2x plus 30, and WV is 5x minus 6. They want us to find all of these segments. Well, if we know right away that this segment, it's supposed to be a highlighter, this segment is congruent to this segment, I can easily say SW is 2x plus 30, and that should equal, right, WV, which is 5x minus 6. So now, when I go ahead and subtract or solve for x, that's 30. Negative 3x equals negative 36. X is equal to 12. So now if I wanted to find the length of these 3 segments, all I have to do is plug that value of x in. SW is going to be 2 times 12 plus 30. 24 plus 30 is 54. WV is 5 times 12 minus 6. That's going to give me 60 minus 6, which is 54. These should be equal, and now TW is 12 plus 40, which gives me 52. And that would be the length of the 3 segments. All right, next, perpendicular, right? Anytime we say segments are perpendicular, these are 2 lines that intersect to form right angles. Okay, so when I look at it, if I have this line and I have this line, and I say they're perpendicular, and the symbol for perpendicular is an upside down T, this means perpendicular. So if these 2 lines are perpendicular, we can say all 4 of these angles at the intersection are right angles or 90 degrees. So when we look at the first one, it says KJ is perpendicular to KM. So right away I know this is a right angle. If JKO is 4 times as large as MKO, right? So basically if MKO is X, we know JKO is 4 times whatever that is. Okay, so how could we use this info to find angle JKO? Well, the first thing I have to do is find X. So what do these 2 angles have to add up to? Well, 4x plus x equals 90. 5x equals 90. So x is equal to 90 divided by 5 will give you 18. So now to find angle JKO, all I have to do is take 4 and multiply it by 18. And right away that would give you 72. So angle JKO would be 72 degrees. All right. Now, an altitude. Altitude is basically a segment that goes from a vertex. Whoops. What's going on here? Vertex perpendicular to the opposite side. Okay, so when I look here, every single triangle could have 3 altitudes. And these altitudes could be inside or outside. For instance, if I drop this altitude down from that vertex perpendicular to the opposite side. Now this one, I can draw another one here, but then I could draw another one here. In a right angle, each leg represents an altitude, right? But if I draw an altitude to the hypotenuse, I would get that right angle there. Now, if you have an obtuse triangle, this altitude lies inside. But if I look at it, is there a way to go from this vertex perpendicular to the opposite side now? No. So what we have to do is extend this side. It's not part of the circle, but it allows us right now, once we extend it, now we can drop that altitude down and make the right angle. Altitudes are very, very, very important when we talk about the area of a triangle. Okay, so make sure you understand that. So next one, perpendicular bisector is a segment that is perpendicular to another segment at its midpoint. So right away, I can have a triangle, I could have a segment, right? It doesn't matter. But for a perpendicular bisector, first you find the midpoint of a segment, so these would be congruent. Then you draw a segment to the midpoint and create that right angle. And that would be a perpendicular bisector. So that basically gives us 2 different pieces of information. So looking at example 6, given PQ is a perpendicular bisector of RS, find the length of QS. Well, right away, we know if PQ is a perpendicular bisector, we know this is a 90-degree angle, so we can say 7x plus 9y is equal to 90 degrees. The trouble with that is we end up with an equation with 2 variables. So what else can we do then? Well, I also know that if it's a perpendicular bisector, these segments are equal. So I know 4y would equal x plus 3. So now if I look, right, what I actually have to solve here is a system of equations. Okay, so first thing I'm going to do to solve this system, you should remember this from last year. Right now, I'm not going to change 7x plus 9y equals 90. But for the second equation, first thing I'm going to do is put it in standard form. So I'd have negative x. So when I subtract x from both sides, plus 4y equals 3. Now what I can do is go ahead and solve this quadratic using elimination. So I'm going to keep the top equation the same. But when I look at the variables, it's much easier to cancel out the x's, but I need to make this negative x become a negative 7x. So I'm going to multiply everything by 7. 7 times negative x is negative 7x. 7 times y is plus 28y equals 7 times 3 is 21. Now the x's eliminate. So 9y plus 28y is 37y equals 90 plus 21 is 111, sorry. And now when I divide that by 3, I get y is equal to, divide by 37, sorry. I get y is equal to 3. Once I know y is equal to 3, I'm going to come back and plug it in up here. So 4 times 3 equals x plus 3. So 12 is equal to x plus 3. And x would equal 9 after I subtract 3. So now to find the length of QS, right, if this is S right here, okay, all I'm going to do is say the length of this is 4 times 3, which is 12, which means this segment would be 12. So QS would be 12 units long. All right. And the last thing here is an angle bisector. And this is a segment, line, or ray that sorry, my pen's not working here, that creates two congruent angles. Okay. So right away here, right, if we have an angle bisector, that means it's a segment, line, array that creates, right, two congruent angles. So right now, if angle RAI, if I trace this, RAI, that's this angle here, is congruent to IAN, this angle here. What that tells me is AI bisected RAN. So our conclusion is segment AI, or sorry, ray AI, right, bisects angle RAN. And the reason is if two congruent angles, then a ray bisects the angle. All right. So it's pretty important to understand that, you know, if we're given certain information, we have to know how to, one, use it to make a conclusion, and then state the reason why. Okay. Go ahead, try the homework, and let me know if you have any questions.